All right, I'm broadcasting.
Okay.
Just started. We were just about to get into it.
Okay.
Okay,
Okay.
so 3, if you guys are into it,
Yeah.
it's number 3 is going to be the third option. HO B1 equals 0 and HA B1 is not equal to 0.
That's what I got too.
Okay, a residual is what is left over after doing simple linear regression. It's the difference between observed value y and the value predicted by the regression line. It's the difference between BO and B1. Depends on the individual variable.
I think it's B,
The
isn't
second
it?
one. I think
Yeah.
so. I'll check my notes here, but I'm pretty sure.
That's what I'm getting to, because just looking at the summary, remember it's the difference between observed and predicted of y.
Mm-hmm. That's what I thought.
A plot of residuals supports using linear regression when you see a pattern in the residuals are all positive. You see when there's
There should be no pattern in it, right?
B.
Yeah, it's the end one.
The residuals look normally distributed with 0 mean.
I think so.
I don't. Let me look at the.
Because usually it just
This
doesn't
was
have
on the
any
homework
pattern.
too.
Yeah,
Yeah,
if
scatter.
you see a megaphone shape, it's bad. If you see a pattern, it's bad. And it could be the residuals all positive, but I didn't think so. I think it's the residuals look normally distributed, 0 mean.
Yeah.
Looking at the requirements summary, what is the question again exactly?
A plot of residuals supports using linear regression when.
So it's just when there's no pattern. Because the residual plot, yeah, you don't want the megaphone shape.
Yeah.
There just shouldn't be any pattern. So you see a pattern, you don't want to see a pattern, so it's not one. They don't have to all, do they have to all be positive?
I don't think so. I don't remember
I
anything
don't
about
remember
that.
anything about positive.
You see a megaphone shape, and that's definitely no. The residuals look normally distributed with a 0 mean. Okay, let's go back to our, it could be that they're positive because, nope, it's not positive. Because the QQ plot for residuals can include negative. Residual plot for the crocodiles was included negative, so it's definitely not that one. You see a pattern in the residuals. Plot of residuals supports using linear regression. I'm just going back through the what was in the text.
Yeah, I'm looking at my notes. I just copied from text and from the videos, so.
Okay, so in the scattered plot, 3.1 in the text, it says that the first thing to check the requirements, we do two things. The first is to make a scatter plot and to visually check to see if there is a linear relationship. And that has been referred to as the hot dog shape, so that would be a pattern. We want to make sure that there is no distinct curvature or other non-linear characteristics. This is simply a visual check of the data. Consider, so it must be the, you see a pattern in the residuals. So what is when you go under the requirements, this is in the homework too, or the prep assignment, but when they were talking about,
This is a plot of
okay,
residuals,
so
though.
that was the key word. For a linear relationship in the requirements, for the scatter plot, you want to have a shape. For a linear relationship in residual plot,
You
want
do not.
a pattern.
That's right.
They don't give us
That option.
they don't.
But it's definitely, so it's not going to be a pattern. It's not going to be A. I don't know about B but I have not read anything about being at all positive. It's not going to be C because if it's a megaphone shape, then that's not a good thing.
Yeah.
So it's got to be D. I mean, the residuals look normally distributed with zero mean.
So what does the zero mean?
Let's see.
Is that just the residuals?
If you guys look under,
that would make sense because it means that you can't have zero mean. No, it says with a zero mean. Now I remember actually reading something about that in the text. Let me see if I can find it again.
Under 3.3 residual plot,
okay,
it talks about the Eutherian crocodile data.
Yeah.
And they have a plot of residuals there, and there's the average is at about 0, but they're positive and negative, and they're normally distributed, kind of. So it looks like all the stuff is close to 0, though.
Which would make sense because the 0 would mean the mean would be on the line, and you want it to be as close to the line as possible.
Yeah.
Like for a QQ plot.
Yep.
Right?
I'm sorry, where were you guys looking? I just barely got into the textbook.
It's
3.3.
and 4. I want to look under really quick the index for what was it, a residual plot that we're looking for? The plots of
So is this the 0 in the middle? Is that the mean?
That's what I'm thinking. That's what we're thinking.
I think so. Under standardized residual. So so I think when we're looking at it, everything's kind of equally distributed out, right? So.
I'm just looking under the index really quick. It makes sense.
It doesn't really say anything about a 0 mean in here, though. That's kind of interesting. I love how they throw in loopholes.
Yeah.
Yeah. Okay, we're looking at Okay, there's a ton. Let me look at the index one first. The difference between, okay. Oh, do you know what? We could probably double check too. Is that it's the quantitative inference. Does it have a mean on there at all? No. It has to be that last one though. Because we know for sure it's not, they don't have a pattern.
Yeah, they're not
Positive
supposed
or
to.
negative, and it's definitely not megaphone, so it's going to be that last one.
I think so.
Okay, 6. Compute the residuals for the math self-efficiency data. So we have to go open that up. Use the confidence data as the X. So we want the confidence data as the A column and the, or, I have to look at that again, is
It's the math efficacy,
yeah,
right?
so explanatory is X. So we want confidence as X.
Where you?
Okay.
Did it say the math efficiency file?
Math efficacy.
Yeah, math self-efficacy.
Yeah, self-efficacy.
My Excel just froze.
Confidence data is explanatory data and score data is fun.
Jeez. Okay.
What statement best describes the residuals?
Okay, finally got it
Sorry.
open.
Yeah, mine's froze, so I'm just got in, so just give me another minute here.
So just double check explanatory. So confidence as the X.
So confidence is X.
Yeah, well, confidence is the explanatory. It's the first one, whatever.
It's the first. Okay.
Yeah, X.
I think it's the first one. The residuals are between -40 and 25.
Fast today, Phil. I'm still plugging numbers in over here.
Me too.
I am slow. Okay, what did it say score then as the Y?
Yes. Response variable Y. Well, I guess it could be residuals form a linear pattern.
Okay. What's the question? I've got it finally plugged in.
So compute the residuals for the math self-efficacy data using software, use the confidence data, yada, yada, yada. What statement best describes the residuals? And
Okay.
I'm looking at the residuals column, and there's none below -40 or above 25. So
Okay.
Let's see.
I'm just thinking now too. I'm slow today compared to you guys. Okay. always
Okay,
takes me forever to open
where's
this.
the residual columns?
It's
Oh.
right next to variable x. It's in E. You just have to look at each number. Each observation has its own residual number.
It does. Oh, okay, I don't know where I'm looking here.
Okay.
Oh, I see. Okay, I'm looking over at the tables. Okay, so it's next to there. So we're looking
Okay, so
for.
it's either going to be that they form a linear pattern or that they're between about 40 and 25 because there are both negative and positive numbers. So does it go all the way down to negative 40 though? Close to that, Bill?
Yeah.
Where does it reach almost negative 40?
Yeah, I'm not
There's a negative 38 in there somewhere. It is
negative 19, negative 14. There's a
number
negative
40.
4.
It's number 40.
Negative 38, okay.
And I just made a QQ plot, or a splatter.
Scatter.
Yeah, scatter plot. There you go. And
Yeah.
they do not. The residuals do not form a linear pattern. It's just like a giant blob.
Okay.
So the scatter plot that comes up though is
That
to
that
the
is
left.
that is
Like a hot dog
just that is just the x and the y's, the explanatory variables and the response variables. If you make a scatter plot of the explanatory variables and the residuals, which it says to do to find out, it's not even close.
Okay.
Okay.
Does that make sense?
Yeah, I forgot about that. When you do you have to do just the D and E columns.
Yeah.
Instead of the X and Y. I'm just double checking to practice too. So
yeah, I might do that myself, but just practice making one because I haven't really tried that yet.
So we just go to insert.
You highlight it, you insert, you make a
Scatter. Oh yeah, they're just all over the place.
Okay.
So on your chart, guys, are you getting kind of one outlier that's in 20, positive 20 area?
Yes.
Okay. And then everything else is just sort of
kind of all over.
twos.
It doesn't have a megaphone look. It doesn't have like a pattern. So.
Okay, so it's got to be the first one then, right? So between negative 40 and 25.
Okay. Okay, based on the QQ plot for these residuals, what can you say about these residuals?
Well, the residuals are not skewed.
It seems that they're normal because if they were, it doesn't really matter if it's skewed unless that's what they're calling a megaphone shape.
Mm-hmm.
And that would be not normal then. And then so 1 and 2 are kind of the same thing, but these are definitely normal. It's just scattered all over the place.
Okay, how do you do a QQ plot from what we've done? Do you guys know how to do that?
Yeah, so you just have to copy and paste the same data. Oops. And then you have to go back to that.
Insert?
I don't know if they have it here. I was going back to descriptive.
Oh, okay.
I'm checking to see if they have it here. No, I'm not seeing it.
Because they always do that line kind of going to like it's diagonal. It's not like a straight up or straight down. So I'm always like, oh.
Yeah, is that how you do it, Bill? Do you just go back to that first?
Quantitative, descriptive, or whatever.
Yeah. And use the QQ plot they gave us.
Yeah.
Okay.
I'm just double checking it too. Sounds like a party at your house, Melina.
Yeah, I've got another child over here playing with my son, so they've got like, it sounds like 3 different things, like electronics going on right now, like Kindle, TV. I told her mom, like, I had like 2 different people call me up to babysit today, or 3 different people call me up to babysit today, and I'm like,
Wow.
I can't, guys. I'm like in my finals weeks. I just can't take any extra, and they're like babies, so I'm like, no.
They
can't
take
do
a
it.
little more attention.
Yeah, but when I've watched this little girl, she's 5. I watched her since she was born, and I'm like, yeah, I can do it because she just plays with my son. So she's not a hard one. But when they're 1 or 5 months old, they take a lot of work, and I can't do that right now. I said, call me in 2 weeks, and maybe I'll say yes, but just can't do it this week.
Okay, so then when you do you transfer, you're just using the residual numbers.
Okay, so you just do the residual.
Yeah, you don't need D and E. You just do.
Okay, let's see. Oops.
Oh, why didn't that go?
Okay. That'll be that for me.
Oh, there's so much transferring here. Okay.
It is. Yeah, it didn't do a QQ, like it didn't do like a line.
It's not letting me do it.
Do you have to do it in like order from highest to lowest, or does that matter?
I don't know. It's not letting me paste this one in either.
Keeps coming up with like a hashtag reference thing.
Yeah, that's what I'm getting. So how did you get yours to paste, Melina?
I just copied and pasted, and then I had to sort it from lowest to highest, and it looks very straight. Yeah, it's fine.
So fairly
Okay.
normal.
Yeah. It stays pretty close. Like, I guess I'd have to insert one of those projection lines, which I don't really know how to do. But how do you put one of those lines in it? But I mean, from what I can tell, they're all
Normal.
Yeah. Do you want me to try to share my screen so you guys can see this too?
Yeah, that would be great.
Okay.
For some reason, it's not letting me paste them either.
Don't let me do it.
I think there's some problem.
Okay, can you guys see?
Oh, okay.
What do you think?
Yeah,
I don't know
that
how to
looks
do
good.
like a projection line, but I think that looks pretty normal.
Yeah, I would say so too.
I thought you were just saying that it looks pretty. Like, it looks pretty.
It looks
Was
really
good?
pretty.
It looks pretty.
No, it looks
So you're
normal.
a statistician when you refer to your QQ plots as pretty.
I am not a statistician. I'm never going to be. I'm counting down the days. Oh, goodness.
Okay, so
So, yeah. So what is it asking?
okay, so
So it's based on the QQ plot.
Which of the 5 assumptions about linear regression are satisfied? There is a linear relationship between x and y, yes, because there's a linear line. There's a line.
The residuals are normally distributed.
That was correct. Looking at the scatter plot, right? Because they were all over the place.
The variance of the error term is constant for all values of x. I think that is one of the requirements.
I need to go back and look at our.
Yeah, the wiki. Let's see. I've got that right up here. I'll read it off to you guys while you're.
Okay.
I wrote down the requirements as well.
Okay, so a linear relationship for the scatter plot and the residual plot, you hope to see a hot dog shape or no pattern in the residuals, so we are good there. Normal error term, the QQ plot of the residuals, points in the QQ plot are close to the line. Is that one of the options?
No. Hold on.
Okay.
No, it's not right now.
Okay. Constant various residual plot, no megaphone shape in the residuals. X's are known constants, cannot be checked directly. X's should be measured accurately and precisely. And observations are independent, cannot be checked directly. Knowing the value. Okay. Knowing the value of one of the y's tells you nothing about any other points.
I think that's true.
So the variance of the error term is constant for all values of x. Did you read anything about that?
Go back to it. It's, what is it? I'm sorry, variance?
The variance, hold on.
It's not in here. Oh, well, it's called the constant variances. It's number 4. The x's are known constants, cannot be checked directly. X's should be measured accurately and precisely.
So it's saying that there are no constants?
X's are known constants.
Oh, known, so you know what they are.
Yeah.
The variance of the error term is, so that one would be 1 then too, right?
I think, yeah. It says how to check, cannot be checked directly. Okay. Yeah. What do you hope to see? X's should be measured accurately and precisely.
Yes. So that one's 1 then.
Okay. So the variances of the term is constant for all values of x, and the x values are measured without error. That is 1. Whoa.
Oh, wait, are you reading the... Are you still reading that?
No, I went back to our quiz. I'm trying to figure out which ones to check.
They're all on there now, yeah. Okay, so which ones? So we want the first, because there is a linear relationship. We want to check the second one, because they were normally distributed.
We want to check the third.
That the term it's constant with all the values of x.
Mm-hmm.
And the x values are measured without error. That was not 1, right?
Or
was it?
For that, it says normal error term. You check with the QQ plot of the residuals, and what you hope to see is points in the QQ plot are close to the line. Does that, I don't know if that answers that question, though.
Okay, so for the QQ plots, we hoped how to check. Oh, we don't want the how to check. Okay, so we just want...
It should be a normal error term.
I'm thinking that's not what they're saying there. We do want that they're measured accurately, because it does say the x's should be measured accurately and precisely. So that would be the 4th one. The variant, I'm thinking we don't want this 3rd one though. The observation, the variance of the error term is constant for all values of x. It's not saying anything like that.
It says constant variance for number 3.
Mm-hmm.
Yeah, but it's just saying that there shouldn't be any, that there's no megaphone shape.
On
in the requirement.
when I wrote it down from the note from the reading, it said variances of the epsilon, which is the error term, is constant for all values of x. So what I have written down is exactly what it says right there in the quiz.
Yeah.
And that you wrote that down as under the
section.
But under the assumptions.
Yeah.
Okay.
So is the independent one? I don't see that one. Observations are independent. Yep, that would be.
In the textbook, it words it a little differently. It says x's should be measured accurately and precisely. X's are known constants. That's the constants variance. So that should be checked. Observations are independent. We got that one?
Yeah.
Okay.
So they all should be checked.
So I think they're all going to be checked.
That's what I'm thinking. That's what I'm getting then too. Because you have to have the linear relationship between x and y.
The residuals
does it say anything though as far as requirements about the residuals being normally distributed? It's not.
All it says about the residual plot is no pattern in the residuals. So it doesn't say anything about normally distributed. But that was the answer to one of the previous questions, so that's what's throwing me off.
But not as an assumption though, right? Or was it just asking if they were normally distributed? Do you know what I mean? I think it was just asking if it was normally distributed. It wasn't saying
that's an assumption. A requirement.
Right.
Okay.
A lot of residuals support using linear regression when the residuals both normally distributed. Man,
so,
this one's a tricky one.
Yeah, it is.
Thinking, that second one might not be in there then. Okay, there are 5 requirements. That there's a linear relationship, that there's normal error term, that there's constant variance, the normal error term would be the third one. The linear relationship is the first one. The constant variance is the third requirement, which is that and that's the
variance of the error term is constant for all values.
No, they're actually not listing that one. They're not listing the constant variance one. Unless that is because that's just that there are no megaphone shapes. So unless that's how they're wording the normal.
Well, in the video, in the video and it looks like, I think this is still the video. It might be the textbook, but yeah, it's called constant variance. Number 3 is the step that they give. In the textbook, that step is called
it's constant variance.
Yeah.
So, but what I'm wondering is the constant variance as the requirement, if that's what they're referring to in the normal distribution, because the constant variance has to do with the residual plot, and if it's a megaphone shape, then it's not. But if it's just scattered all over the place, then it's normally distributed. But is that a normal distribution, or is it just, I don't know about that one. The last 3 are definitely in there though. The x's are known.
I just read in the reading, it says once the residuals have been calculated, we can assess if they are normally distributed using a QQ plot. If the points in the QQ plot are close to the line, then we conclude that the residuals are normally distributed.
So I don't think that's a requirement then. It doesn't sound like that's a requirement then. Or else they would have listed something about normal distribution as a requirement. Do you know what I mean?
Where did I write that then?
So in the text, it's listed under 3.5.
Oh, right there at the beginning of 3. It says check requirements of simple linear regression.
Okay, where's that?
It's right at 3.
Checking requirements of simple linear regression.
There's 5 steps.
In order to do a hypothesis test, blah, 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 there is a linear relationship between x and y. The error term E is normally distributed.
Okay, we got that.
The variance of the error terms is constant for all values of x.
Okay, we got that.
The x's are fixed and measured without error.
Got that.
And the observations are independent. So it would be all of them.
So, but it says, my only question is, it says that the error term for E is normally distributed.
Oh, so you're saying error terms and residuals are not the same thing?
Yes.
Okay.
Because E is the word for, that's what they use for epsilon, right?
The true regression equation.
It's not.
E is a normal random variable. So I think you're right, Dina.
So 2 is not going to be checked. The residuals are normally distributed.
Because, okay, what are the residuals? Are the residuals the random variables, though? What exactly are the residuals?
The residual for an observation is defined as the difference between the observed value of y and the value that would have been predicted by the regression line. As an equation, this is expressed as residuals equal y minus y equals y minus b0 plus b1x.
So yeah, so they're not this. It doesn't sound like they're the same thing then.
No.
Okay. So we click 1, 3, 4, and 5.
Yeah.
All right. What is B1 the estimate for the slope?
Are they talking about
the math efficacy? Okay, so back to that.
I got 12.725.
Yes. $12.725, right?
Yeah.
What is the confidence interval for B1?
I got the first one.
I have 10.708 and 14.742.
Yep.
Okay. Based on the evidence using a level of significance of alpha equals 0.05, what decision would you make regarding the hypothesis test for B1? So what's the...
P-values are really small.
Yeah, the p-value is like 0 practically. So you would reject the null.
Because P is less than A, right?
Yeah. But so I have a question about this. During the reading, they were talking about using finding the degrees of freedom. I just opened up the normal ANOVA.
Mm-hmm.
Is there a different one that I should be opening? Because it definitely did not look anything like what they were showing in the book.
You should have the linear regression.
Yeah, you should be in the t-test for linear regression.
Just
I know,
right.
but when they were finding the t-test for linear regression, where's the degrees of freedom?
Oh,
Remember when they were talking about that?
yeah.
They were saying to use the ANOVA, but in the ANOVA it doesn't have anything. It didn't look anything like the page that they had shown. Anyway, I was just wondering. It doesn't look like there's a question about it or anything, but I couldn't find it. What they kept
Well,
referring
you
to.
never know if they're going to ask it. They'll probably throw it in the homework.
So for the hypothesis test for B1, the slope.
Okay, I'm looking at the.
Oh,
I'm sorry. Were we gonna look up the degrees of freedom, or are we moving on?
Oh, yeah. Let's just move on.
Okay.
We can look for that later.
In a minute. Okay.
Yeah.
All right.
So we would say that there is sufficient evidence
to conclude that the slope of the regression
Is not zero, right?
is.
If we are rejecting the null, then
Let
we're.
me look at my other ones because I've done this a few times today. Let's see.
I really wish that they would just say yes or no. Like, there is insufficient evidence to conclude.
Yeah, it should be does not equal 0. So there's sufficient evidence to conclude that the slope of regression line is not 0.
Okay.
Okay. And for the crocodile data, which variable is the dependent? So the dependent is the second one, so it would be
body length.
What was it? Body length? I thought it was.
No, because you measure the head, and however big the head is, it tells you how long the body is.
But the dependent.
Yeah. Oh, the independent is the head length, and then the dependent would be body length.
Yeah.
Because you're predicting the body length using the head length, so the body length is dependent on what the head length is.
Yep.
So the dependent is the y variable then? Yes. Right?
I think.
Yeah, the dependent is y, and then the independent is x. Yeah, explanatory variable is x, and the other one is not over far enough. And the response variable, dependent variable, is y.
The independent is supposed to be. Oh yeah, so the dependent is y.
And that's the response, the one that's being predicted.
Right. I was just making sure I'm not confusing that in my head. Okay, since the 99% confidence interval for this data is 7.124 and 8.311, what can you say about B1?
Oh, I've got this written down. We are which one's?
Oh no, it's not chance.
99% confident that the true slope. Oh, it's not going to have that in there.
I think it's I think it's the first one. That since the confidence interval does not contain 0, there is significant evidence to conclude that B1 is not equal to 0. It's basically just restating what we said above, because it can be insignificant suddenly. So the bottom one's down. There is no chance in any of this, so the second one's out. So that has to end since
it's not a chance. Yeah, there is insufficient evidence to reject the null hypothesis.
And since our null hypothesis is, or our alternative is that it's not equal to 0, then it has to be the first one. Right?
I think so. There is not, because there's no 0 in that equation, right? Isn't that? Don't they talk about that? There's no negative, so it can't be equal to 0.
Yep.
Since the confidence interval does not contain 0, there is sufficient evidence to conclude that B1 is not equal to 0. Yeah.
Yep.
Yeah, that is true. So, all right.
Before we click on though, oh wait, so we got for 9, 12.725, right?
Mm-hmm.
Yep.
And then the only other one I'm just still scared about is that
8. I think we got it.
the residuals are not normally distributed. Okay. Because it's not talking about the term is normally distributed. But are those residuals? That's what I'm just not sure about.
I don't remember reading anything that said that residuals are error terms.
It would be
So-
at the top. Let me see. Let me go back to the top of that lesson. Okay, so we add a term called the error term to this equation. This is a random variable, and we denote it by the Greek letter E, pronounced epsilon. That doesn't have anything to do with residuals, though.
Well, it's saying that the true regression equation then is blah, 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 plus the residual, or plus the epsilon.
Mm-hmm.
So it couldn't, you can't have, if the
The residual for
epsilon,
an observation is defined as the difference between the observed value of y and the value that would have been predicted by the regression line. As an equation, this is expressed as, so it's not saying that anything about residuals being an epsilon, same as the epsilon.
and if the formula to find the residual includes adding the epsilon, then the residuals in and of themselves couldn't be only the epsilon being normally distributed. Does that make sense?
Yeah.
Residuals
The
are
residual is calculated for each data point, so you have one residual for every observation in the data set. It is hard to use so many numbers to make decisions. How do you comprehend so much information at once? Okay, yeah, it doesn't say anything about it being the same as epsilon, so.
I'll check one more thing too. Epsilon. How do you spell that? E-P-S.
E-P-I-S-L-O-N, I think. Let me see.
E-P-X-I-L-O-N. Yep.
Yeah.
I'm just going to look and see if it says in the index if it's the same thing. And it's not even on there. So. All right. Should we just
Submit? Okay, let me go back to it.
okay, epsilon.
Oh, are we submitting now?
Yeah.
Are we ready?
Yep.
Okay.
93. What did we miss?
Is it that one?
Yeah.
Yes.
God.
It doesn't tell us which one, though. It just says that we got it wrong.
We need to ask about that because that is so unclear.
Yeah, it probably was that all of them were in there. It doesn't say what we missed, though, like in that. I think we should get partial credit, too.
I do, too, at least because it does not, nowhere in the reading does it say that the residuals are the same thing as the epsilon. It says that to get the residuals, you have to add the epsilon in there, but it doesn't say that it's the same thing. Do you know what I mean?
Right.
anyway.
Yeah, I'm not a big fan of that. That's my name.
No, me either.
No, it's a 93. But yeah, I think we could probably get partial credit for that, like at least half credit. So,
I am actually flying out this morning to get back home, so I'm not going to go to that. I can't go to the meeting.
okay.
But, will any of you guys be able to make that?
I won't be able to. I've got to take my son to an appointment.
I will try. I've got like a lot in my trying to get done this week, so I'm gonna see. I'll see if I can go, but
Okay.
I just don't have like an hour and a half to spend for this one question. That's what I'm
I
like.
know.
So
If
it
not,
seems
we
like
still got
every
another
time I
week.
go to his office, it takes like an hour, hour and a half, and I'm like, I just don't have that kind of time today
I
to do
know.
that. So, and I think my business class wants to meet this afternoon about at that time. So, well, I think it's a little later. But all right. Well, I'm going to stop broadcasting here.
Okay. What are you guys' who's next on the
I believe I